You alluded to automation, and I was actually wondering to what extent can some of these challenges be overcome with greater automation? You can have too much
Mhm.
automation to where it becomes I guess you could say, a liability or a burden. And there are certain areas where you can target it with the right amount of automation. So I'm just wondering, can some of these workforce challenges be overcome to some extent with automation?
I do believe that you can, and well, in the packaging side, yes, but you still need, I would say, 25-30% automation can probably help it. But the rest is not. You need people. You need humans.
Hello, everyone, and welcome to the Altium On Track podcast. I'm your host, Zach Peterson. Today, we're talking with Jeff De Serrano, President of North America Division with PCB Technologies. PCB Technologies is a manufacturer, and you all know that I love to talk to manufacturers to get a better grasp of what's going on with the manufacturing side of the industry. Jeff, thank you so much for joining us today.
Glad to be here.
So, you and I talked briefly at PCB East last year, and it feels like a whirlwind since then. A lot's changed in the industry. And I know that some things have changed with PCB technologies, which is one of the reasons that I wanted to get you on here to talk about it. But maybe before we get into some new developments with your company, if you could just introduce yourself and then what PCB Technologies does, what end markets you serve, things like that.
Sure. My name is Jeff De Serrano. Been in the industry for around 34 years. Like I said, I'm the president of PCB Technologies USA. We have we're a sister division of a company called PCB Technologies that's based in Israel, and we are a flex, rigid flex, HDI company building circuit boards for many different market segments: defense and aerospace, communications, satellite divisions, onboard medical, basically medical applications for onboard or on human products as well. So we're very diversified in that part of the business.
So obviously, there's a lot of different manufacturers out there. It sounds like one of your competitive advantages is pretty broad expertise because you bring up things like HDI, satellite, medical. I imagine some of that stuff is also high reliability and takes some manufacturing expertise that maybe the quick turn guys or some of the overseas folks don't really have.
Very much so. Again, a lot of defense and aerospace. So basically, every airplane that the United people in the United States or around the world fly on probably has one of our circuit boards in it because we've been building for Rockwell Collins and Collins Aerospace for probably 20 years. And their main customer is Boeing, 737s, 787 Dreamliner, 777s. We build a lot of the circuit boards for the radio communication equipment inside the Boeing aircraft, and also the high performance landing gear communications in the landing gear to the cockpit. That's just kind of one area of expertise. We think we have a distinct advantage because we have three different divisions. We have a circuit board division that started 44 years ago, and we've been advancing technology as we've been going on for the last 10 years of really advanced technology. And then we have a CCA facility that's in the same campus, about a $70 million assembly facility. And then we launched a division called Impact. I think it's probably why we're talking. We launched that a year ago at IMS 2022. And it is an advanced packaging division, all in the same location. So it's sitting right on top of our circuit board factory.
Yeah, so that brings up the topic that I was really excited to talk to you about, which is packaging, like you said. Um,
Sure.
so advanced packaging, obviously motivated by the CHIPS Act and semiconductor shortages in general. But I want to know really what motivated a company like PCB Technologies to begin this investment in packaging production and in capabilities.
I'm really proud of my CEO and our private investment firm that owns. We're a public company in Israel, 150 million, but there's a private investment company, PE firm, by the name of FEMI that owns around 48% of our stock. In 2018, they hired a new CEO. His name's Ovid Shapira, and then they felt there was an opportunity in the advanced packaging area for faster cycle times. Okay, you go across the water and you deal with the big guys, Kyocera and all these folks. Their lead times are 12 to 18 months for NPI, and then they another 24 months in ramp production, and they do millions and millions. And so they saw a window, and then unbeknown to them, COVID hit. So then the CHIPS Act came in after COVID. They had already invested the 19 or 20 million dollars for all the capital equipment and the infrastructure and the building and the people and all that. And then so by the time COVID hit, it kind of put us in the back burner just a little bit, but they kept building. And now with the CHIPS Act, they're reshoring wafers. It's a little bit different than packaging. So now, I think the defense industry is starting to realize, because you bring the wafer back, chips don't float. Everybody can hear that. That's kind of the new term out there in the industry with the PCB AA group, Travis Kelly, and from Isola. Chips don't float. So now they're going to build the wafers here, but now they're packaging back across the water again. So they got to cut the wafer. They got to bump the wafer. They got to do that. The equipment and stuff that the team put in, we do all that in one location now. So we've taken what takes 5 supply base for a customer like a Intel or a Qorvo or any of these guys that develop chips. They have 5 different supply chains they have to use to get their product to market, to test. And we put that all in one spot. So it was a visionary from the team, the upper management team, on the packaging side. It's very unique. The lead times and cycle times that we're able to accomplish, either build to spec or build to print, is a year shorter than the other guys, right? So we can take the wafer, they can build them here, we can take the wafer, we can bump the wafer, solder bump it, we can cut it, we can use the microelectronics assembly on it, which is different than my CCA facility. Okay, it's different. This is a very, very unique assembly operation, wire bonding, so forth. Package it, we can and go from there, right? The whole thing, and all in one spot though. So we can do like a 3 to 6 month window to production. Now, we're not going to be 5 million a month, 10 million a month components, but the defense and aerospace industry doesn't need that. And they need a couple 100,000 a year of very specialized products. So
you said that someone like Intel, let's say, they might rely on 5 different supply chains. Could you just clarify real quick what those 5 different supply chains are?
Well, so they've got to get a substrate board built, right? Then they've got to take the wafer and have it bumped or dyed, right? Now, they might do some of this internally themselves. Some of the big guys do. But then they have to go to production, so it has to be taught over there. And after that, then they have to go to the assembly facility that's going to take the wafer and put the substrate on, and then do the wire bonding and all the other little components that go in it. And then they go to the package house that's going to take the whole thing and put a lid on it. That's basically, they put an injection, not an injection mold. It's a material, a plastic material. They make a lid, or we're doing SIPs, system in package, where we're taking multiple ones and stacking them and putting them in a package. So there's a market that now Intel, a big guy, might have a lot of this in-house for prototype runs and so forth. And the defense and aerospace, I know, has some of this capabilities in-house, but they limited to very, very small quantities, right? So that's the 5 market segments we're talking about. They've got to do packaging, they've got to have a substrate or an interposer built. We do that here at our facility. Because we were a board shop, we built things in panels. We outfitted the substrate facility in the same format. It's just a smaller. And then we made it sub-tiers so we can build it in the microelectronics area, right? Again, the deal for us is they can come to us with a print and we can build it from all the way from the start to finish in the same location. And then we can also take a statement of work, SOW, and they say, hey, I have a package. It's this big. We need to make it this big. And it needs to be this price point. And then we can help them design it and get it built in the same place. Very, very unique.
So is this only silicon and organic interposers with 2D or 2.5D, or are you doing 3D stacking of dies as well?
We are doing 3D as well. Yes. So we're able to do the copper pillars and then stack on top of each other. So we do 2, 2.5, and 3. Okay. Most people don't understand what that means when I talk about that. So I'm glad that you asked that question.
I think a lot of industry groups are pretty clear on the role that packaging plays in the chip onshoring movement, and they see it as a really critical part of the supply chain. Now, industry groups and maybe some people in government may see it that way, but obviously you have to ask, how well does this translate over to industry such that you can have a sustainable supply base, hopefully one that's profitable and doesn't require subsidies? So, to what extent do you see this playing out in North America, in Europe, or in other regions of the world that are outside of Southeast Asia?
Well, I think there's more talk going on in the DoD and the Defense Department right now about putting some money out because they see, bringing the wafers again, chips don't float. They got to send it back. So they're looking at putting money and investment into the packaging side as well. In the U.S., even our company itself is looking to replicate what we have in Israel and put it here for the defense guys for some of the really black box stuff that they do not want going, even though we're an ally and we're an ITAR company and AS9100 and NatCap and all the stuff that goes around with it. They still don't, some of them don't want to send some of it. Okay. So I think you're going to see some changes in the next maybe 18 to 24 months, 18 to 36 months. People are going to start, they're going to go after the money first and try to do a startup, right? I think in the end of the day, there'll be more of those companies onshore to support the TSMCs and the Intel and the guys that are doing the wafers here, the Texas Instruments and the Qorvo guys and so forth. I think you're going to see an influx of people trying to jump into the game. But I have to tell you, it's not the easiest thing to do. If you can jump in the game and put $10 million down or $12 million and buy the equipment, you got to have the people, the know-how. This is a very, very advanced technology, to say the least, right? You've got to be able to. Now, the substrate boards are still going to be built somewhere, and there's not a lot of companies in America that can do sub 25 micron lines in space, which we're doing in Israel, but we've been doing it for 3 years now plus. And we're going to go more advanced, and it's a modified semi-additive process. Then you're going to go to semi, and it takes a big investment so it's not just packaging, right? So you gotta get all the components. It's basically building a component for the customer. It's a SIP or an MCM modules. They're components, right? You're building a very, very advanced technology component now. Yeah. And so I really see. We probably will have one relatively quickly in the U.S. Customers are asking us. We can duplicate the pod. We have the resources and the people to do the training and then start this division up. I'm just not ready. We're not announcing anything yet. We're not ready. We're not there yet. We're close.
Well, that's fair, but I guess the progression that I'm hearing from you more broadly, that maybe we can expect here in the U.S. or North America more broadly, is driven by DoD first, so supporting the defense base because that's really where the critical need is, and then eventually branching out
Right.
to support the Intel, TSMC type of companies that are going to need this packaging capability locally in order to support their existing onshoring efforts, because those plants aren't going to come online overnight. They need some additional time. So I guess the broader
Correct.
commercial packaging capability also doesn't need to come online overnight.
I agree, and I think what they'll do is they'll end up using the U.S. operations for more of a advanced, time critical production of the package. Again, when you go to commercial, it's very large volumes, and overseas you have to pick A, B, C, D, or E line, and you design your product to go to that line. I'm going to go to A line, and I'm going to get $2 million a month. It's going to be this. I go to B line, it's this. C line, it's certain design characteristics that you have to adhere to in their design rules. With us, we're more flexible, so we can do all of them, and you don't have to pick a line. But again, they're going to need capacity here to do faster cycle times than the guys across the water. And if the wafers are here already, it only makes sense that there's going to be probably 3 or 4 players that are going to put these up and going to support the faster turn, right? So it's ever going to come. I don't know about the money. I'm still studying about the money from the DoD side. The CHIPS Act, $50 billion, and there's some more money allocated. I just haven't got to the bottom of it yet.
Well, you bring up the money, right? The capital expenditure sounds sizable. So I think that means that you're really only going to see this kind of capability come from really the larger manufacturers. Probably they already have operations overseas to support that capital that's already needed. And if they're larger, they can probably get private capital to also support those investments. Is that fair?
It's a fair assessment, right? I don't think the little guys, to do what we're doing in Israel for just the microelectronics assembly side and the system and package business unit, it's not a huge. It's probably $6 to $12 million depending on what you're doing and where you are. But again, it's people, number one, besides the investment of the dollars, and you still have to have the substrates made, or the interposer, whichever you like to call it, to make the 2.5D and the 3D. So, there's multiple parties around again that are involved. So I do think the bigger guys on the wafer level side will eventually probably get some of the money and put packaging places here. That's what I think. I'm not 100%, but I don't see many circuit board manufacturers doing it. Like, I don't see the guys that where I came from over the last 30 years. I don't see them investing that money into the MSAP, ASAP, small form factor build up technology, right? And then do the packaging. I don't see that happening. I think it's going to be more the semiconductor companies looking at getting it and getting some money to do it and putting them up. That's what I think.
Well, I'd agree with you. I don't expect every, mom and pop shop in the US to start looking at, packaging capabilities necessarily just because of the capital level involved. But it's interesting that the semiconductor companies might also move into packaging. And I think it makes sense because it reduces some overhead.
Right. And it's time to market
Sure.
too. It's think about the speed, right? And because they're going to build them here, they were doing it all over there because of the cost, and that's where everything is. And so everything's over there. So if you're going to bring that here, why are we going to build it here and send it back there to get it done and then bring it back over here? So it's kind of, I think the CHIPS Acts are great. I like staying here in America and the American allies. I think it's important. But they kind of forgot about a certain part of the business, which I think they're now paying attention to. Everything I'm reading, they're starting to pay attention that's you can't just bring the wafer here, right? You're gonna have to do more to really make America self-sufficient again.
Yeah, and I would expect to see the same type of thing happen in Europe to an extent as well.
Yes, I have to agree. Yeah.
So, we've talked about a couple of challenges here, one of them being capital, but you've brought up twice so far, the workforce. And having people who are competent or who at least have the basic level of knowledge to the point where they can be trained up to then be competent operators and users of this technology. There's probably also some design education that's needed as well. Could you maybe elaborate on some of the workforce challenges?
All the reading I do, you can look at TSMC. They announced just recently that they were supposed to be ready in 2024. And they're not going to be ready until 2025 now because they don't have the workforce. They don't have the people. I just read an article, I think it was on Monday. They don't have the know-how and the people with the know-how to get the plant running. So that's just on the wafer side, let alone think about the other side, which has not been here. How long has packaging been gone? Since the 90s. It's been over there. So if they're having trouble with bunny suits and the clean room environment for automation, because it's a lot of automation in the wafer side, Think what they're going to have the challenges to do when it takes people to the know-how and do this advanced packaging. So, but I think that's a challenge a lot, even in the circuit board industry. That all of my competitors are friends of mine at the same time, right? We all have the challenge of the younger generation not getting involved. It's not a Google. We're not Google, and we're not Apple, and we're not these guys. You get sleeping pods and stuff, but we're also not GM where you're turning a screw, right? The equipment now costs $1 million, $800,000, $1.5 million. So we're all kind of in the same boat. We need mentoring programs. You need something going around the U.S. where these kids in the summertime can come to work with us, right, and learn how to run and operate these things. So I think that's probably you can put a pod in all you want, but the proof's in the pudding when you don't have anybody to teach you how to run it and teach the next guy how to run it or how to do it. And I think it's going to be a big challenge. I think it's going to be a big challenge.
You alluded to automation, and I was actually wondering to what extent can some of these challenges be overcome with greater automation? Because we just recently talked to somebody at Marquette University, and they're working in the Omron Innovation Lab. And this guy has brought up the point that automation can kind of be a pipe dream. He didn't exactly say it like that, but you can have too much automation to where it becomes I guess you could say a liability or a burden. And there are certain areas where you can target it with the right amount of automation. So I'm just wondering, can some of these workforce challenges be overcome to some extent with automation?
I do believe that you can, in the packaging side, yes, but you still need, I would say, 25-30% automation can probably help it, but the rest is not. You need people, you need humans and interaction and visual and so forth. So wire bonding, things of that nature is semi-automated right now. The person does a certain thing, the machines do the rest, but then the quality inspection is done on certain machines. That can probably, as the years go on, get automated. You're still going to need people. It's like thinking of, when I think about this. I've been in the board business a long time, printed circuit boards. And 10 years ago, I said, you know what? We're going to have the semiconductor facilities inside our shop eventually, because where we were going then, it was like 4 mil lines in space or something in HDI. And now look where we do. We have, at least in our facility, we have, partial wafer semiconductor stuff in our own printed circuit board shop. And so, but again, I don't know how we're going to do automation and get away from people when the advanced stuff that we're doing today. How do you stack die and so forth and do a SIP, a 3D model, and have it all automated? Again, I read the article on TSMC. They were going gangbusters, and they're automated probably around 80% in their processes, I think, to make the wafer. It could be even more than that, and they can't start their building up. They're not going to be able to. They're going to have the infrastructure, and all the stuff is there, but they're not going to be able to fire it up because they don't have the people. And it's very much automation. So, I think automation is fantastic, but I don't think it's going to get to where it's 95 or 98% automated.
Right? Yeah. My hope is that, young people who like to solve complex technical problems, who probably would have been attracted to going to a Google or a Facebook or some other, tech company in Silicon Valley,
right,
will see some of the challenges in manufacturing, and will say, well, hey, I want to do that.
Right. That's what I was talking about. We need to figure out a way to get them in an internship in the facilities, because to teach them, they're not a GM worker turning a screw. Nothing against those teams, but that's what the mentality when you say manufacturing. They think, oh, I'm going to have a boring job. Listen, what we build today makes the world go round. Okay? And what you fly on every day, we put stuff in. What the missiles that you're shooting across the the world, and the guns and the weapons and all the stuff. We make that stuff, right? So we try to. The younger generation needs to understand that, and like you said, it's problem solving, right? That's not automated. Somebody sees a problem, we give them a task, and they go try to figure out how can they solve that problem through microelectronics, because everything is doing the miniaturization, so to speak, right? The real estate's big, they want it a little bit smaller, but they want to double the function out of it. And how do they do that? They miniaturize. And that's where the substrates and the advanced packaging and the SIPs and the MCMs come in play. You take a board that's 2x4, and you're out of real estate, and you make it a 1x1, and you double the throughput because you put a 3D component on that board, and all that board this big is now something this big, you know. So we're in for, I mean, we're in for a challenge just because of the workforce, I think, big time.
You know, you brought up a really great point, and this is something that I think when I was younger kind of drove me away from manufacturing. When I was younger, I thought I wanted to, go work at Intel, be in the bunny suit, and I'm kind of glad I didn't. But
Right.
when I was a kid, my parents both, blue collar. My dad was a cabinet maker, my grandpa was a cabinet maker, and they both said, don't work in a factory, don't work in a cabinet shop, go learn to
Yeah.
do something with your brain. And I did that.
Yeah. Yeah.
And it was under the impression that, manufacturing was always going to be like you described, some person on an assembly line, turning screws by hand
Right.
or attaching bolts to something or whatever. And
Right.
I think over the past 20 years, it's really become totally different. And I would agree with you. Kids really need to see that it's not like that anymore. It really is problem solving, and even, computer programming. If that's what they want to do, they can do it in a manufacturing
It's
environment.
changing the world. I mean, seriously, the circuit board industry has never been a sexy industry. Okay, it's a lot of chemistry. It's but again, the stuff we build, we make sure that our factory workers understand what we're building, and we show them all the time, so they understand what they're doing on this part of interlayer. When the final product's done, it's over here in this thing that's protecting the world, or on an aircraft that they fly on, that they go on vacation and things. And I think it's super important to somehow get the young generation in. It is automating, again, the industry that we're in. There is automation, but that doesn't take the worker out of a job. It teaches them to do something else, and then we cross train, and you learn how to do this, this, and this, so you don't get, bored of doing the same thing over and over, and you can move around within the organization, and you can get more knowledge and growth and try to help solve problems.
Well,
Right?
speaking of automation, one area, of course, that is, of course, you have to be living under a rock to not know about it, and I know you know what I'm going to say, is AI.
Mhm.
Um, we've talked to some people recently who are looking at targeted applications of AI in factories, one of which was to handle things like traceability using vision systems, which I think makes sense and is targeted. Um, are you expecting or investing in the use of AI at all in production facilities? And do you see greater proliferation that produces positive ROI?
We are not investing in the AOI as of today because we're investing so much in capacity and technology. Do I think AI is going to be helpful in 10 years in our world, in my world where I'm in? Yes, I do. So it's something we're looking at. Right now, we're currently just investing the money where we think can grow the business and help our stock, right, as a public company. So I do think AI is going to help. I think it has some challenges right now. I mean, it's really neat stuff, but I think for what we would use it for, it's still a little ways away for us.
I would agree. I think anything really skill heavy and knowledge heavy that's more niche, it still has a long way to go before it really has
Correct.
broad applicability.
Right. I agree. Yeah. I mean, that's just. But hey, you know, driverless cars, they thought were going to be ready to roll pretty soon. I still think they're 20 years away because it's just 15 and 20 years. The technology is getting better, 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 but it has to be perfect.
Mm-hmm.
So that can't be better.
Yeah, it can't be good
You're talking
enough.
about, no, it's got to be perfect, right? It's not like it can be okay. It's got to be perfect. And so but it's going to go there. And when they take my driver's license away, by that time, it's not going to matter to me. I'm just going to get on an app and say, come pick me up anyway. It's not going to
Well,
matter.
there you go. That's the right mentality. I think we're getting towards the
Yeah.
end of our time, but you brought up, some
Yeah.
growth aspects in the industry, and obviously you're investing in packaging because you see the growth prospects. But what other areas of the printed circuit board market, or the electronics market more broadly, do you see having large growth? Maybe areas like flex or rigid flex?
Rigid flex and flex. They're getting rid of cables in a lot of areas, and because it's just a direct connect, and they're using rigid flex because they can get rid of two products over here and connect them over here, and they make it one and fold it. So not a lot of folks in the United States are doing rigid flex, and especially for aircraft and defense market industry, it's a big growth. It's a big growth for us. It's about 60% of our business is rigid
Oh, wow.
flex. Now, with that said, we do think Impact, the substrate advanced packaging division, will outgrow our circuit board thing in the next 5 years, just because of what is happening in the world. But again, it's a serious growth market for us, and I think in the printed circuit board industry and stuff, it's flex and rigid flex for sure.
Yeah, you brought up aerospace. That's kind of typically where it's existed, and so it's almost like it's come full circle.
Yes, and if you're really good and you can build some really challenging HDI large form factor rigid flex, it puts you in a good spot. And that's another thing like the PCB company, PCBT, focused on. We build very large form factor panels, and that was one of the really exciting things for me being in this business for so long. I didn't have that opportunities. I had to give them away all the time. There's only one company that could do it. So now there's more. And if you can do that style of business and quicker and be nimble and have a decent production area for it, you can really do well. Yeah, it's good.
Okay. Well, as all of this evolves, I'm sure we'll have you back on in the future, or we'll invite you back on in the future to discuss this and see how it all falls out.
Right on. Yeah, glad to be here.
Great. Well, thank you so much, Jeff, for talking to us. To everybody that's been listening or watching on YouTube, we've been talking with Jeff De Serrano, President of the North America Division for PCB Technologies. If you are watching on YouTube, make sure to hit the subscribe button. You'll be able to keep up with all of our tutorials and podcast episodes as they come out. And last but not least, don't stop learning, stay on track, and we'll see you next time. Thanks, everybody.